Okay, so this is going to be our second video for Unit 3, Day 3 in Algebra 2, second of four. Okay, so in this video, we're going to talk about how to use the calculator and algebra to derive a square root function from a set of points or a data table, right? So if you want, go ahead and pause the screen and read the problem. I'm going to go ahead and go right into it. So what we're being asked to do, namely here on number one, really, is to derive, well, on one and two, we're asked to follow some directions. And then ultimately at the end of number two, we're asked to derive uh, our function here, basically, because all we're missing, according to this, is the a term, right? So we're trying to get this a times the square root of the length of the swing, right, relative to the time. So that's important because obviously that's our stretch factor, right? And we can easily do this by just entering in data into the calculator, which is not new. So what we're going to want to do is run a regression. And to do that, well, we need to follow what it says on number one. We're going to make a spreadsheet. Clicked on the wrong thing by accident. We're going to create a list and spreadsheet, right? Nothing new. So put in X for A, Y for B. Okay. And we have to remember now X and Y are our independent dependent variables respectively. So in this case, our independent variable is the length of the swing. Our dependent variable is the time. It's kind of weird to think of it that way, right? But that's what we're being asked to find is time as a function of the pendulum swing, right? So our x values are not going to be time. Our x values are going to be the length of the swings. So first, I'm going to enter in those. Those are my x values. So 6, 10, 14, 18, 22, 26, 30, and 34. Okay, then I'm going to come back up here. And I'm going to enter in my y values. So these are my time values. So zero point 0.8, 1, 1.2, 1.35, 1.5, 1.6, 1.75, and 1.85. All right, so now we've got them, and then this part should look familiar. We're just going to go to statistics now, go to stat calculations again, and we're going to hit power regression this time, just like it prompts us to do on number two. Nothing really changes from here. X list, of course, is X. Y list, of course, is Y. Just hit enter a few times, and the calculator gives us a whole bunch of crap. Okay, so let's look at what we've got here. So it gave us a function in the form a times x to the b power. So a times x to the b power, right? Well, we learned maybe in the previous lesson. Again, I don't remember. They're starting to run in together if it was the previous lesson or not, but x to the 1/2 power is the same thing as the square root of x. Okay, so when you see that, we know that that's the same thing, and that goes back to the fractional law of exponents, the law of fractional exponents. So if I have x to the a over b, that's the same thing as the b root of x to the a power, right? So x to the 1/2. Okay, so that's what the calculator is telling us. And it's telling us that the a value is 0.33. So a is about 0.33. And it's telling us that b, so this exponent here, is about 0.50. So about 0.5 or about 1/2. Okay, so that means a is approximately 0.33, and that also means that our actual function t of L is going to be about 0.33 times L to the 0.5 power, or 0.33 times the square root of L. which is the form that we actually wanted here in the information. Right, so now let's talk about how we can do that just with pure algebra. So using this first point right here, 6 by 0.8, we can use that to also approximate the value of A, right? So if I'm saying that T is equal to 0.8 and L is equal to 6, well, I just plug in to that into this right here. So I'm going to say time is 0.8 whenever A times the square root of the length, which this time is 6, right? So all I'm going to do is solve for A, right? So I'm just going to divide by the square root of 6. So 0.8 divided by the square root of 6 is going to be equal to A. And come back to our calculator here. Let's see if it'll let me move it over here without being stupid. Nope, it's going to be stupid. I'm just out of luck. There we go. Okay, so go to calculate. And all I'm going to do is 0.8 divided by control x squared, the square root of 6. And holy dog crap, we get again that A is about 0.33. Okay, which is more accurate? I'm going to be honest with you. The calculator's determination of it is going to be more accurate, but we don't always have a graphing calculator, so obviously it's going to be pretty useful to know how to do this algebraically. Okay, so that does it for this video. Like always, if you have any questions or anything, shoot me an email. Otherwise, you know where to find me. Goodbye.